So as Levi said, I'm William Pallister, director from Portage La Prairie, Manitoba. I hope everyone enjoyed our reception last night. So on our farm, technology is crucial to the competitiveness and viability of our operation, from cellular weather stations connecting to my phone to satellite maps connecting me to my fields. So our next speaker, Kirk Wesley, represents Case IH AFS Marketing Manager for North America. He works with the latest technology, connecting Case machinery to the cloud. We thank Kirk and Case IH for being proud sponsors of the Wheat Growers. I don't know if he chipped in himself, but if we are, we're thankful. So let's give Kirk a warm welcome.
I'm a little shorter than everybody here, so I'll move the mic down. Good morning, Kirk Wesley. Case IH, I work as AFS Marketing Manager for North America. So what that is Advanced Farming Systems. I've been with the company for about 13 years in that capacity of technology ever since I started back in 2006. So what we're going to do here today is keep this a little light, but what I've got is some slides that I've put together on the 5 levels of autonomy. And if I can find the clicker here and figure out how to use it right, what we'll do is we'll step through these, and I'm going to do this fairly quickly because I would really like to get your opinions and leave time for questions. I think, Dave, we've got 30 minutes, is that right, as we go through this. So what we'll do is we'll go through something that we've put together, just establishing kind of what the autonomous vehicle and the path to getting to that autonomous vehicle is about. So many of you probably saw in the press and so forth in 2016 when we had the concept tractor for the autonomous vehicle that we showed at the Farm Machinery Show, Farm Progress Show down, I believe that was in, I think it was Decatur that year. We go back and forth between Iowa and Illinois there. But anyway, we had introduced that at that time and stood there and listened to the people come by, many people just like yourself, and start to question what this machine meant to them. Did they like it? Did they not like it? Where was it going? How could they use it? And it was a very, very interesting event when we were at it. We are continuing to develop this technology. One of the things we are not going to do is the cabless machine as you go forward. Maybe in the future, far off into the future, a cabless vehicle would be something there, but it's just, you know, you guys work with these things. The price of these machines is just outrageous, and we need to kind of double time that and have the ability to climb in and work with that in other operations. So the autonomy, what we're doing with it is all going to go forward, but it'll probably most likely appear in the marketplace in the next 5 to 7 years with a cab on it and just the functionality that goes into that. So we are evaluating them. They're out on farms right now. We've got a few, and I'll show you an example of one as we go through that. So what we've got are 5 categories. What we want to do is put a stake in the ground so that as we're talking, just as important to us as anybody else, in fact, and I see a fellow from John Deere here in the front row, they approached us and they said, let's put together some sort of a autonomous concept of what the path will look like as we go through it. So we did that, and we laid it out into the marketplace since we introduced that machine in the first place. And all OEMs really are adopting this, and this is what they're going to follow. And it's fairly simple. We've got the guidance, we've got coordination and optimization, we've got the operator-assisted autonomy, then we go into supervised autonomy, and then the full autonomy, which was that vehicle that you saw there in the beginning. On the guidance portion, we've been doing this for quite a while. In fact, I think the very first guidance that I worked with, I was a crop consultant for 20 years prior to taking this job. So I'm an agronomist by training, and we were using GPS and yield mapping and out to do soil samples and so forth while I was doing that in central Illinois. And we got in very early with this guidance. It first appeared as a light bar on the vehicles. Anybody use those light bars back when it first started? And then it started to get integrated, and what we're talking about here is more of using the hydraulics on the machine in conjunction with the satellites and the algorithms on board the vehicle to go in and guide that vehicle back and forth on, at the time, it was straight A-B lines. Obviously today we're into the curved lines, we're into pivots, we're into all sorts of different types of ways that we can run these machines, but guidance is the first step in what we're working with there. The next one we get into, if it advances, Matt, there it goes. We've got the coordination and optimization. So this is now where the machine, in this case, and the example that I've put up here is with Isobus. Anybody familiar with what Isobus is? So basically, in a very simple way to imagine this, Isobus is the smarts are on the implement behind the tractor. So how to run it, the buttons, the layout on the screen, all that is kept on board of the implement. And we reserve a site in the display in the cab of the vehicle that can be seen, and the network between the implement and the tractor is kind of like cable TV, if you will. And we reserve a channel on our display so that it can come up and you can interact with that machine on this display. It doesn't have to be a Case IH product, nor does it have to be a Case IH tractor to go in to plug it. So Isobus is a uniform way to share all this information back and forth between different suppliers. When it came out, we had Class 2, and Class 2 basically is just that. I plug it into a 9-pin on the back of the tractor, and there it is on the virtual terminal, one of the pages that we reserve on there, and I can actually press the buttons and set them up, and it looks the same on my display as it does the Deere display, as the AGCO display, or even third-party people that have the ISO technology into it. But we've now moved to one step further, and that is Isobus Class 3. What Class 3 does, and why I've got it on this screen right here, is now that implement, a baler in this case, has the smarts to ask the tractor to speed up, to slow down, to get more horsepower so that it can compress. And what it does is the implement, based on the crop that it's going through, senses what is going on that machine and then asks the tractor to give it the optimum speed and horsepower to be able to accomplish what is going on there. So now we've got this implement telling the tractor what it needs. So that's the Isobus Class 3. Baler was the first one that we came out with, and we're working on planters as well as many of the competitors out in the marketplace. So this is something that goes in and goes with the coordination and the optimization segment. The next one we go into is operator-assisted autonomy. What this is there's a guy on board, but now what we're doing is the machine and the software and the algorithms are out there actually working with the tractor and the implement, and the driver or the person in the vehicle is just kind of along for the ride monitoring what's going on. And instead of going through and do this, I'll work with Matt back here, and Matt, why don't we go with that top one there with AFS Soil Command, and before you hit OK, let's go in, and what we're going to see here is we've got a brand new product out there, and what it does is it's just on a tillage piece of equipment, and it goes in and self-levels in depth and back and forth in the way that we're trying to figure out the best or make the best seed bed for eventually that row unit dropping the corn to ride on. So if it's kind of bouncy under there, where the shovels and that are going through and it's not a real flat surface, you can imagine as the row unit's going, it's bouncing along and we're losing the ability to drop grain, corn, wheat, whatever, behind that in a nice flat. So go ahead and let's hit that OK on that. It'll kick in here. And that's okay on the sound. I apologize for sound. Some of these marketing people with what we're doing with videos just drives me crazy. So you can see on here how this is going along and see how it's kind of bouncy and what it's doing. So what it does is it's got the feedback for the wings and what's going on, and it'll go in with the hydraulic cylinders and it self-levels. And you can see the shovel now is running a little smoother. Now when the seed goes in, it's nice and flat. You're not getting that bouncing that's out there. So all it is nothing more than just preparation. So that's one of the ways that the implement can do it. And Matt, why don't you hit X up in the top right? Just exit out, and then we'll go to that AccuTurn. So AccuTurn is the ability to go into the end rows, and what I want you to watch here is in the cab of the vehicle. And you're going to see a snippet of one that we'll talk about a little bit later. But all of this is coming out. What we're working with here is coming out of that autonomous vehicle, that concept vehicle that we worked with. We had to solve those problems when nobody's in the vehicle, and what you're going to see, or what you are seeing, is as we release new vehicles out there, just as with our automobiles, you're starting to see a lot of that technology come out in little bits and pieces into the marketplace. So let's go ahead and hit OK, and we'll watch what we're doing on AccuTurn here. So this takes the steering, straight steering back and forth, obviously we've had, but I want to watch, or have you watch at the end row, what this vehicle does. So as they turn, you're going to see the guy just is along for the ride. And it brings it right back in, and it keeps everything. So you see in there that he's not steering that. And you see that vehicle, there's not even anybody in that one. So that's where we're heading, and I'll get to that in a minute. So this is the concept from above of what it's doing. It's making its own turn. It knows the width of the vehicle, or how far it needs to go over. And then it just drops it right back in, sets the thing back down, and then you can see some of the information on the right. So that's the AccuTurn product. And we needed that. If we take the driver out of the tractor, you've got to have that. How are you going to turn it? Or things going to go straight and just circle the world if it could possibly do that. So you can see here there is the interaction. It's not totally automated. The guy will engage when he wants to turn, or as he's coming up to an end row in this next screen, you'll see here where it knows that an end row's coming, and he just confirms it, and it'll do its business when it gets down to the end. Okay? So Matt, let's go ahead and just X out of that on the top right. And then the last one down here that we're going to look at is our harvest command. And this, what I want you to take away from this video, is all of the sensors that are involved to make this happen. Now this is on our new 250 series combines, and what this is all of the sensors that are in that machine that are talking to automatically set this machine as it's going through the field based on the grain flow and what is coming into that. It knows how to set the sieves, set the fan speed, and everything in there to get it done. So Matt, let's go ahead and click OK. And this one might have a little voice on it, so we may want to just minimize that. So this is harvest command. Get through the stuff. I just grabbed marketing video, so I apologize because that's what we had there, but it did a good job of showing what's going on. So you can see as it goes in, what we're going to do is just see this tremendous amount of sensors that it's going to start to call out here, everywhere, all over this machine. And to be honest with you, I haven't counted, but there's probably in the neighborhood of 20 sensors or more that are in there that just are watching, including 2 cameras on each side of the rotor that are watching the grain flow out of that, and it can also sense the amount of grain that's going through and do some settings on that also. So all this type of technology, if we're going to steer these vehicles, if we're going to automate them and nobody is on board, this type of thing has to be in place first before we can roll it out into the marketplace where it's going to be automated as it goes through. And then we'll let this go a little bit longer, and it shows coming up here pretty quick just the grain moving through the vehicle. So not only do we need to know what's going on in the machine, what the grain is, we got to know how it is, how it's sitting. Is it on a side slope? Do we have to level the platform and so forth? So what you can see here is how it's moving through, and then how all these sensors are working to watch and reset what's going on in that machine. Ultimately, when we get all done, there's no grain coming out the back, and it's automatically set, and no matter what conditions it goes through or finds in that field, it automatically is adjusting as it's moving through the field in real time. Okay, I think this goes out. So let's X out of that, Matt. So those are, basically the operator is still in the cab, isn't he? He's sitting there and making sure everything is okay. He's watching what's going on in the back, but he's not really doing much of anything other than babysitting the vehicle to make sure what it is. Now, what's the reason that we kind of have to do that? It's the public. We could move this along a lot faster, but the problem that we get into is we're not a mining or a construction operation where we've got a controlled environment with a fence around us and a no trespassing sign and all that. We are out on the roads with people. We are driving these machines on the roads with the public. So, number one, the liability from an OEM manufacturer is just out of this world, and you gotta be really careful what you do out there. And number two is you've got to be darn sure that this thing is completely safe and nothing's gonna happen as it's driving or transferring from field to field as we go through there. So a lot of what we're doing is the operator is in there. You know, this next phase that we're getting into with the supervised autonomy, what this goes into is more, you'll see maybe one operator, and you'll see a clip in this, in the one that we've got here. And Matt, we're gonna need the sound up on this one because I'd like this guy so they can hear what he's talking about. He says some things. He's a farmer for this, and he says a few things of what they're looking at and how it is being useful to what they're doing on their operation. So if you can go ahead and start that. This is Bolt House Farms. Bolt House Farms is probably in everybody's supermarket. They've got a little bit of everything as they go. Okay, perfect. So he's going to go through and show you how we're working with these two machines. Now these machines are completely separate machines, so there's nobody in them. One of them there is, and then if you look in the background, the Steiger that's right behind him as he's sitting sideways doesn't have anybody in it. So it's kind of a paired trailing type situation. So we're trying to get the sound going here. I'm supposed to dance and so forth. How about I take a question from somebody while we're getting the sound up? Anybody got a question on what we're talking about? So we don't lose any opportunity.
Is it on?
There.
Great presentation so far. Really just more of a comment. My husband and I have been working together on the farm for many, many years. And some days are good and some days are not good. And there's an awful lot of nonverbal communication that happens between, say, a grain cart driver and a combine operator. And we've had to work through a lot of issues along the way, and I'm just wondering if you've maybe considered, since your implement and your tractor have to work a lot of hours together and talk to each other, if you've maybe considered some counseling or something that might have to go along with that kind of communication over many years.
Yeah,
maybe a date night, I don't know.
Yeah. Well, if we can go full autonomy, date night can happen a lot more. That's the thing that we're doing. So you guys can both sit at dinner and enjoy yourselves while the vehicle's out there doing its thing. So that's the end goal, is to make a happy marriage. So, but yeah, you're exactly right. We don't want to take that away from you if that's something that you're looking for. That's not my purpose to be up here, but how we doing, Matt? We good? Okay. Hopefully don't blow you guys out with the sound here.
Challenges that a lot of other large agricultural producers are facing. The global population is growing at an exponential rate, and producing good quality food for the growing population is something we all need to focus on, not just in the ag industry, but across the world. We're striving to use technology in every facet of our operation.
Thought we had it in there. Well, you can get the concept here, so I'll step in here. So basically what he's talking about is how Bolt House Farms is using this. They're looking for this automation. They're baby carrot growers. So these guys, most of the baby carrots in North America are them or Grimway are the two big companies. So what we did as a project with them and setting up with these vehicles where we wanted to do tillage and in the autonomous side of it. So what he's talking about here is how that goes in, and you'll see this machine where it gets to the field, and you can see it automatically sets itself up and then goes out and away it goes. And it just takes off, and it's using a lot of the technology we looked at in those earlier videos of going through and setting it. So you can see him, and then the tractor behind him doesn't have anybody in it. It's just trailing behind what's going on with that. So this is the next step of where we're at with the autonomy side of it. And this is the first thing you'll probably see out in the marketplace with any of the OEM manufacturers, is going in and working with the labor issue. You know, we just hate to say, oh, guys, you start getting into this, guys and gals, we got technology in here, and you've got to have operators that know what they're doing in there. And a lot of rural areas don't have some of those people there, and that's just the facts. They want to integrate this type of technology as quickly as they can and get this going because they can't find skilled operators. And it's not only here in North America. All parts of the world have unique situations, unique circumstances. The one I heard about, we're setting up quite a few RTK plus cellular base stations in South Africa. That's a crazy place. It's just an absolutely crazy place because there's a huge percentage of those people that won't be alive next year when they train them because of the AIDS and some of the issues that are going on out there. And these operations are coming to us for, I can't rely that I'm going to have a labor pool next year. I don't know if they'll be around. And so they want the technology to help offset what's going on, and it's a very, very sad situation that that's the way they want to implement technology like this in those areas of the world. But it's something that they've got to look at and go forward to be productive in what they're working with. And it's just kind of a sad state in certain parts of the world. As with the sugarcane situations that we work with our sugarcane harvesters in a lot of places where you got to be very, very, very careful not to disrupt society and just all of a sudden put 6,000 people out of work because you can automate their jobs. And a good sign of that is Florida Crystals and out at the Dominican Republic. If you look at their farming operation out there, they've got, I think it's 150,000 acres, and it's all harvested by hand still. It's really, and they use ox and throw it on there, but that's the labor pool, and they don't want to disrupt that, although they're right up against it right now, wanting to bring automation into those areas because they want to be able to see that from their control centers in their operations and feed that information into it. So it's really kind of an interesting concept of how we integrate and what we're doing with this, with automation. Because we can do it isn't always a reason to do it, is the thing that we got to pay attention to. So full autonomy, that's the vehicle that you've got down there. You know, ultimately, that's where we're headed. So those are the 5 steps that we go through with the autonomy side of it and what we're looking at. And then the last thing I wanted to step on, well, there they are just in this, and if anybody is interested in this type of stuff, you know, I can leave the presentation for you, or you can get a lot of this stuff on the web. Just type 5 categories of autonomy, and this will pop up on one of our websites, I'm sure. The last thing I wanted to touch on is we've got all this, what's happening with the data. Data is heading to the cloud from all of our vehicles. Everybody's doing this. The next big challenge and what's going to change agriculture is what we do with that information. And next week is the National Farm Machinery Show down in Louisville, Kentucky. 2 things happening. One, you'll see a brand new Magnum tractor be introduced there with new screen, new technology in it. And it's based on this product right here, which is AFS Connect. The AFS Connect is the telematics product that we've got out there. This is my baby. So this is, I do the digital world. This is my job now of working with the information and your data, keeping it your data, to be able to share with who you feel and want to through this AFS Connect product. And it's basically farm, fleet, and data. The farm side of it is the agronomic side. That's your yield maps, your prescriptions, your AB lines, your boundaries. All that is the information that you use to work day in and day out on your operation. The other one, or the next one, is your field, or the field side of it, or I'm sorry, fleet side of it. The fleet is the machines, all the CAN information, all of the speed of the tractor, the def levels, the fuel levels, all the CAN data of what's happening on that machine, the temperatures, all that is also available to look at and see. And more importantly, if you so choose, you can partner with your dealership, and what you can do with that is he can watch for maintenance. He can watch for signatures that are happening. You may get a phone call and say, you know what, we have a problem on these Steiger tractors. Don't worry about it. You're still 70 hours away from it, but I can see the signature starting to develop of this failure that's going to go, and I'm going to order the part right now. Sometime in the next 2 weeks, I'll come out and fix that. You won't ever excel to that level because we can intervene, but we know that it's a problem and we know that it's happening out there. It's all in the name of keeping everybody up for 100% of the time during your workday. If we can look at this and step in before we get to a major issue, then we want to do that. And that's what a lot of this software does. So it shows all that information, the engine hours, it shows your temperatures. You can see all this, plus the fault codes. Every time a fault code is thrown, it can go in there. Notifications, we can go in there and say a lower limit and an upper limit. So I want you to harvest. I want you to drive this combine, and I don't want you to go faster than 6 miles an hour, and I don't want you to go slower than 4 miles an hour. And then you can set those parameters in there, and if that operator for 90 seconds, let's say you set it, if it's in that state at 3.5 miles an hour for 90 seconds, the manager gets a text. So the machine will say, I'm not operating in the parameters that you want in there. So that helps you let the machine tell you that it's not being, and you're not going to get the production that you need for that day to finish the number of acres that you need to get through. So you can have that type of thing start to go in.